On January 14, 2019, an automobile accident occurred at the intersection of Taft and Dallas Street in Houston, Texas, between a compact car driven by Mr. Garcia and a tractor-trailer driven by Ms. Wakefield. The court has asked your accident investigation agency to provide a comprehensive analysis of the collision from a physics perspective. Your team must put together a formal report for the court that assesses the claims of both drivers and determines if one or both of the drivers is at fault. So, first and foremost, the car driver, Mr. Garcia, claims to have made a full stop at the light before entering the intersection, and claims that Ms. Wakefield did not slow down prior to entering the intersection. Ms. Wakefield, the truck driver, claims to have been braking before the collision and that Mr. Garcia did not stop at the flashing red light. So a couple of things that we are informed of is that the distance of the car after the collision is 8.2 meters, and the distance before is 13 meters. Additionally, we're told that the weight of the car is 13,600 newtons. We're also told that the force of friction for the car is 100 newtons, and the normal force for the car is 130 newtons. Furthermore, we are informed that the manufacturer of the car claims that the maximum acceleration for the said car is 3 meters per second squared, and the angle of separation for the car is 33 degrees. Now, moving on to the truck, we're told that the distance after collision for the truck is 11 meters. We're told that the weight of the truck is 69,700 newtons. Furthermore, we're told that the speed, or at least the speed that the truck driver claims, is 6.7 meters per second. Additionally, we're told that the frictional coefficient is 70% that of the cars. Now let's talk about friction. Friction is a force that opposes motion when you have two surfaces touching each other. And there's two types of friction. You have kinetic friction and you have static friction. Static friction is the friction of objects that are stationary, and kinetic friction is the friction of objects that are moving. We do not need static friction, so let's focus on kinetic friction. To find kinetic friction, you simply divide the force of friction by the normal force, and for the car, that amounts to 100 newtons divided by 130 newtons, which is about 0.77. Now, this is the coefficient of friction for the car. We know that the coefficient of friction for the truck is 70% that, so 0.7 times 0.77 is equal to approximately 5.4 for the truck. Using this, we can find the force of friction. Once again, force of friction is the coefficient of friction times the normal force, which is mass times gravity, or also defined by newtons. So for the car, it would be for the truck, it would be 37,638 newtons. Now we want to find the accelerations. Using Newton's law, we know that force equals mass times acceleration. From this, we determine that the acceleration is equal to force divided by mass. And in the case of the car, in the case of the car, we get approximately 7.5 meters per second squared as the acceleration of the car, and the acceleration of the truck is equal to And this gives us 5.3 meters per second squared. So these are the accelerations for the car and for the truck. So now let's find the speed of the vehicle after each collision. So we're going to use this equation. So this first one is for the truck. We get that and this comes out to approximately 9.1 meters per second for the car. Now for the truck, we do the same thing. And it comes out to approximately 10.8 meters per second for the truck. So now, let's find the speed before the collision. And to do that, we'll use the law of conservation of momentum. So we know that the momentum in the beginning should equal the momentum at the end. So let's start with the car. Once again, we're using the angle of separation here. We're going to use 10 angle of separation there. So this gives us the velocity for the car of 12.8 meters per second, approximately. So now, for the truck, we're going to follow the same procedure. So this gives us a velocity of the truck of 12.5 meters per second. So once again, velocity of the car, velocity of the truck. So, going back, all of this data tells us that 12.8 is, this data tells us that both Ms. Wakefield and Garcia are to blame for the crashing. They are both equally responsible as their actions led to the crash. Once again, to recap, we used physics principles to determine who was to blame for a car accident, and as it turns out, both Mr. Garcia and Ms. Wakefield are to blame. So from this, we can gather that plus Garcia equals crash. Once again, just to solidify this, using physics, we were able to figure out who was to blame for a car accident that we were not at. Alright.